Task number 5. Mamba number 5. There was a song, Mambo number 5, I think. So, task number 5, routing. Consider the network diagram shown below. It only has 3 networks. However, how can the internet figure out how to deliver a packet from network 1 to network 2 or network 3? Although this is an overly simplified diagram, we need some algorithm to figure out how to connect network 1 to network 2 and network 3 and vice versa. So here we have, let's say, just for the sake of this diagram, here is the internet, right? It's just something that we need this network to work. So in this diagram, we can see, let's say, the 3 big networks that this diagram basically displays. And these networks are basically different computers, different devices, all over the city or over the world. And here we have the internet. And what can we do to make the network 1 connected to network 2 and network 2 to network 3 or network 3 to network 1? Well, we can consider a more detailed diagram. The internet would be millions of routers and billions of devices. The network below is a tiny subset of the internet. The mobile user can reach the web server. However, for this to happen, each router across the path needs to send the packets via the appropriate link. Obviously, there is more than one path that is route connecting the mobile user and the web server. We need a routing algorithm for the router to figure out which link to use. So from the mobile user to the web server to the office user, all this communication needs a router, and this router needs an algorithm to figure out how to make this path work. The routing algorithms are beyond the scope of this room. However, we will briefly describe a few routing protocols so that you become familiar with their names. OSPF, Open Shortest Path First. OSPF is a routing protocol that allows routers to share information about the network topology and calculate the most efficient paths for data transmission. It does this by having routers exchange updates about the state of their connected links and networks. This way, each router has a complete map of the network and can determine the best routes to reach any destination. EIGRP, Enhanced Interior Gateway Routing Protocol, is a Cisco proprietary routing protocol that combines aspects of different routing algorithms. It allows routers to share information about the networks they can reach and the cost, like bandwidth or delay associated with those routes. Routers then use this information to choose the most efficient path for data transmission. BGP, Broader Gateway Protocol, is the primary routing protocol used on the internet. It allows different networks, like those of internet service providers, to exchange routing information and establish paths for data to travel between these networks. BGP helps ensure data can be routed efficiently across the internet, even when traversing multiple networks. RIP, Routing Information Protocol, is a simple routing protocol often used in small networks. Routers running RIP share information about the networks they can reach and the number of hops, meaning routers hop, required to get there. As a result, each router builds a routing table based on this information, choosing the routers with the fewest hops to reach each destination. So basically, the objective of task number 5 is just to display for you some networks, things that we read already. Here is a network made of 2 computers. Here is a network made of a server and 3 computers. Here is another network made of a fax, a laptop, and a mobile device. Now, here we have 3 distinct networks in the same building or in separate buildings, or one in a neighborhood and network 1 in a neighborhood and network 2 in another neighborhood, and then network 3 in network 1 neighborhood. Or then we can create a scenario where network 1 is a city, network 2 is another city, network 3 is another city, and then lastly, we can say that network 1 is in one country, network 2 is in another country, and network 3 is on another continent. But how they all can talk with each other? Well, via the internet, which is the biggest network of all. Well, how then? Again, how does this network work? How is this possible? Via routers, and these routers use some protocols. Here are some. These algorithms basically make it possible for devices all over the world, all over the country, all over the building to communicate with each other. Answer the questions below. Which routing protocol discussed in this task is a Cisco proprietary protocol? EIGRP.